Welcome, welcome. Today we're going to talk about algorithms and methods. This will be lesson 0.4. It's pretty heavy, there's a lot of content to this one, so I'm going to try to chunk it into smaller pieces, which is exactly what we're going to talk about with methods, is how do you chunk your code so that it's smaller and easier to understand and everything isn't just all thrown into main haphazardly. Okay, so first and foremost, let's talk about what algorithms are, because we're going to be looking at our code from this perspective from here on out. So an algorithm is a step-by-step process for performing a task. So you're just trying to do something, it could be anything you want to do, and break that task down into steps. Now you can imagine that since programming is all about telling the computer to do things in some particular order, computer scientists are very fond of thinking about different algorithms to do things. They're always on the hunt for the fastest way to do something, or the way that requires the least amount of computer space. You know that there's a hard drive and the hard drive only has so much space on it, and larger programs require more space. So there's a push to always find a better, faster algorithm to do something. Here's an example of an everyday task you might want to do. You could desire to make cookies. Now I personally am not a baker, but I looked up how you make cookies on the internet. Anybody can make cookies if they want to by doing this. And so what's an algorithm for making cookies? Well, we could think big picture. So here's a big picture algorithm for making cookies. First, you prepare the ingredients. So you get all your things together, then you mix the batter. So you put the ingredients together into cookie form, and then you bake it, right? So that'd be a pretty general algorithm for making cookies. So you could tell someone that's made cookies before, oh yeah, you just got to get the stuff together, mix it, and then bake it in the oven. Now this isn't a very great algorithm for a cookie novice like myself. I need these things broken down into more specific chunks, right? So if I want an algorithm just for prepare ingredients, that might look like this, right? I need to get the oven ready first, right? This is kind of my first step. Let's preheat the oven. We need 3 cups of flour for the number of cookies I want to make, so I'm going to set aside 3 cups of flour. I need to beat 2 eggs, and then I need to put butter, a cup of butter, white sugar, and brown sugar all together, and then mix it till it's all, it's all mixed together. So this is an algorithm for that one step. So what we're doing here is called procedural decomposition. Ugh, that's a mouthful. Basically, we're coming up with a set of procedures for a larger task and breaking it into subtasks. And this is really what we have to do as computer scientists. And there's a lot of leeway in terms of how small of a breakdown do you need to get. If we go back to this example, it's possible that, cream 1 cup butter, white sugar, and brown sugar, maybe I don't really know what this looks like, and I need to break this down further, right, into another set of steps, right? And so I'm just decomposing this one big task, one complex task, down into smaller and smaller chunks. Okay, so and where you need to stop is kind of left a little bit up to you as the programmer. So again, breaking a complex task down into simpler algorithms, this is called procedural decomposition. When you approach problems this way, you end up creating programs that are nice and adaptable and modular, so they can be used in a lot of different contexts. So let's say go back to this example. Maybe I beat 2 eggs into like this one nice chunk, right? So beat 2 eggs. Now I could also use this same idea, beating 2 eggs, for making an omelet, right? So that's like a totally different program, totally different task. But if I made my code nice and modular, I'd be able to apply the same idea, the same beat 2 eggs thing, to this other context, okay? So that's when you make your code this way, when you kind of unitize it into these little chunks, then it's really nice and adaptable and modular, okay? Which is what we want. And again, this is an art to determining how much you need to break this down, and not so much a science. And you will, as you program and as you get more comfortable doing this, you'll be able to make decisions and you'll get a feel for what's the right size. How many lines of code does it feel like is the right amount for a chunk, okay? All right. Again, to reiterate on this, if you break things down too small, if you make them a little bit too fine, then your code can look clunky and overbuilt, like there's too much going on. You know, you're trying to swat a fly and you bring out a bazooka, right? Not really very helpful. And if you make the code too large and too large of chunks, then your code just looks pretty, it will end up looking pretty messy, and everything, you know, it needs to get separated out a little bit further. It'll be easier to understand that way. So, and it won't be as modular either, because, you know, this one chunk is trying to do too much. It's trying to do too much stuff. Okay? All right. So, how do we do this? How do we chunk our code? How do we take something that's big and complex and break it into smaller units? And that we'll talk about this as the way to do that is with static methods. Java, other object-oriented programming languages, we'll talk more about what object-oriented means. We're going to break our code into static methods, and they're just named chunks, so you have to decide what to call it. You know, just like we had prepare ingredients was our name, they're named chunks of code that are reusable. So you can keep reusing the same code over and over and over again. You don't have to retype out all of the instructions every time you want to use it. So we already have a static method, which we have to have every time we want to run a program, and that's the main method. But the other methods we're going to write are going to look very similar to main. Okay, so here's an example of why static methods might be useful. Pretty straightforward. Let's write a Java program that's called toBoxes. So public class toBoxes that prints this, you know, these 2 boxes to the console. So we've got a plus, and then looks like 4 dashes, and then another plus, and then a vertical line. In case you're curious about how that vertical line is created, it's above the enter key, and it's the shift of the backslash character. So here's, backslash looks, backslash, there it is. It's leaning to the left. The backslash character, above it, if you shift that character, you're going to get the vertical bar is also called a pipe. I don't know why it was called a pipe, but that's another name for it. So that pipe with 4 spaces and another pipe, and pipe, 4 spaces, another pipe. So let's try to print this to the console. So I'll give you a minute and let you set this one up. So why don't you go ahead and open up IntelliJ and then try to solve this, and go ahead and hit pause on the video and then resume the video when you've finished. Okay, so hopefully you got a solution for this, and it should look something like this. Right? So here's public class, toBoxes, that's the name of our program. Here's our main method, public static void main, string bracket bracket args, open curly brace, and then we just have this big blob of system.out.printlns, right? We have plus dash 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 plus for the top, and then we've got the middle, top, top, middle, top, something like that, right? So we have all these all these print statements, just one after the other. Okay. Thoughts, observations. What is redundant about this? Redundant meaning, what are we repeating? What seems unnecessary? Well, we repeated this 4-line chunk of code, right? The plus, dash, 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 plus, then these, middle line spaces, middle line spaces, middle line, plus, dash, 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 plus. We repeated this four-line chunk of print statements twice, right? So that seems a little bit redundant. It seems unnecessary. We want the computer to do these kinds of things for us, and we're just going to say, hey, let's just make a box and then do it twice, right? Why not? So to do this, we're going to use static methods. So there's a better way. There's a better way than just writing it all out in main, right? So writing all those system.out.printlns. We'll create a static method, and we want to name things well so that they're easy to understand, so that future us go back and look at the code that we wrote, a year ago or 6 months ago, and it's still understandable. So we're going to name this thing drawBox because, we have the choice of what to name it, and that seems like a pretty suitable name for this, right? We're just going to draw a box. One thing to note is that it's camel cased with a lowercase to begin with, different from how we've named our classes. Remember, our classes have been camel cased with the first letter being capitalized as well. So classes are unique, only those get the capitalization on the front. All of our other things that we name, we're going to do a lowercase starting and then uppercase after that. So it's going to be drawBox, right? Okay. So here's our method. This is what it looks like. Public, static, void. Those words should all be very familiar because they're the first 3 words we wrote for main. Public, static, void, main. But instead of main, we're going to say the name of our method, which is drawBox. 2 parentheses with nothing inside, so just an open and closed parentheses. And you might ask, well, why are there parentheses? We'll get to that in a little bit when we talk about how you can pass information to methods. And then we've got an open curly brace and a closed curly brace. Java uses these curly braces to kind of say what's within. What is inside drawBox? What are all the pieces that we need for this method, right? And to draw a box, we just have those 4 printlns that we noticed were repeated, the ones that were redundant. This set of 4 statements accomplishes the task of drawing a box. So, all right, let's move on. So that doesn't completely do what we want to. Just having that method created, we have to also tell main, we have to do what's called calling the method. And calling is where you have the program say, hey, go do the stuff that we said was called drawBox. Okay? So if we declare it, which we just did on this side, this is creating the method. We're declaring this method. Nothing is going to happen yet. We have to actually call it in main, and we'll show you how you call it in main in a second. Okay, so this is our main method. We stripped everything out of it. We stripped all those system.out.printlns, and now all we do is we put the name of the method we want to use, which is drawBox, with parentheses and a semicolon. So we're just saying, hey, go find drawBox wherever we've created it and just run all the code that's there and do that twice. Okay? So all in total, this is how our program will look with the redundancy eliminated. Okay? A thing to note about where this method lives, where it lives inside the class. Now, It is inside the class. Everything is inside the class except for just a few exceptions. So our method, drawBox, lives in the class, 2 boxes, and it's adjacent to the main method. What I mean by adjacent? Well, it's not inside. It's not inside the main method, right? Here's the, let's get a little pen out here. So here's the open curly brace for the main, and there's its closed curly brace here. So we don't have the drawBox method, which is all of this, within the curly braces of main. So all of this is outside main, right? But we call drawBox in main. Okay, so we have 2 calls to drawBox here. So what this is going to do is it's going to, the first call, it's going to head down, it's going to say, hey, find drawBox. Oh, this is drawBox. All right, start with the first line of drawBox. So it's going to print out that top and then process all of these lines in order. Okay, we're done with drawBox. So what do we do when we're done with the first drawBox? Well, we go back up to main, and then we do drawBox one more time. This is why it's really handy. It's reusable. We don't have to say, okay, print all these things out again. So we've already figured out what drawBox is. We can just call it one more time, and the computer will say, okay, all right, let's go find drawBox. And then we're going to go print, and then when we're done, we bounce back up. Oh, this is getting a little messy. We bounce back up, and then we find we're done with main. We've hit the main closed curly brace. Our program is finished. So at the end of all of this, we've drawn 2 boxes. Okay. All right. If it doesn't make complete sense right now, we'll get some practice with it, and we'll start to make more sense. So I'm going to go ahead and pause the video here. It's getting to be a little bit long, and we'll pick up